Hello friends, Namaskar. Welcome to Professor Sahu Academy. In today's video, we'll learn about the mathematical model versus econometric model. So the mathematical models are basically the deterministic model which show the exact relationship between the variables. On the other hand, the econometric model is called as the stochastic models which shows randomness in the relationship. So we'll try to understand about these two models by step. So first we'll discuss about the mathematical model. Mathematical model. So these mathematical models are the deterministic models. Deterministic models because it show exact relationship between the variables without randomness. For example, suppose we are having a mathematical model where y is equal to 5 plus 2x. Okay, this is a mathematical model and it will show the exact relationship. How? If the value of x will be equal to 10, then how much will be the value of y? So here from this equation, from this mathematical model, we can say that if value of x will be equal to 10, value of y will be equal to 5 plus 2 into 10. That will be equal to 5 plus 20 will be equal to 25. That means if x will be equal to 10, y has to be equal to 25. So means this shows the exact value, exact amount of x when exact value of y when the value of x is given. So means there will be no randomness, no different value. For one value of x, there will be only one value of y. But if we'll compare this with a econometric model, it will be little different. Now we'll discuss the second model, which is called as the econometric model. Econometric model. Econometric models are also called as the stochastic models. These are also called as the stochastic models. Stochastic model actually incorporates randomness by including an error term. Stochastic models, we can say stochastic models incorporate randomness by including an error term in the equation. We'll try to understand this. Suppose we will just write the previous equation, that is y is equal to 5 plus 2x, and which was the mathematical model, and if you are including a error term, that is u, this will become a econometric model or stochastic model. And here u is very much important. How it is important? Because u represents random influences such as omitted variables, measurement error, and expected shock. Okay. Now we'll try to understand this with an example, and the example here will take as the consumption function. We'll take the example of the consumption function. So by taking the example of the consumption function, we'll try to understand how to create a mathematical model and how to create the econometric model. Here we'll take the mathematical model. So as you know, in the consumption function, consumption is a function of income, and we can write the mathematical equation as C will be equal to alpha plus beta y. Here alpha is the intercept or the autonomous consumption, beta is the slope coefficient or the marginal propensity to consume. Details about this consumption function is explained with our previous video, and the link is given in the description. Now if you know the value of alpha and beta, for any value of income there will be exact value of the consumption. You cannot say that there can be any value, rather there will be only a single value of consumption for a single value of income. For example, suppose alpha or autonomous consumption equal to 100 and beta value is equal to 0.8, and income, suppose it is increasing by 1000. Suppose the income of the individual is increasing from 0 to 1000. So the income now is equal to 1000. How much will be the consumption? It will be equal to 100 plus 0.8 into 1000. That means 80% of 1000 income, that will be equal to 800. That will be equal to 100 plus 800 equal to 900. That means if the person's income will be equal to 1000, he will be consume 900 out of that. So means this will be called as the mathematical model, because if the income will be 1000, the consumption will be only 900. That cannot be any different value from the 900. So it shows a exact relationship, exact value of dependent variable for any particular value of the independent variable. But this may not happen when we'll say about the econometric model. Now we'll apply the same example for the econometric model. So the second model is the econometric model. Econometric model. So here if you are explaining the consumption function, where consumption is a function of income, the econometric model, it can be written as C is equal to alpha plus beta y plus u. U is the error term. And here we are including income as a independent variable which may impact your consumption. Along with that, there can be other important variables which may also affect the consumption of an individual. For example, it can be the age of the individual, whether the individual is a child or he is a young person or he is a old person. Accordingly his consumption, it will be affected. Similarly, another factor which may affect the consumption of the individual, it can be the gender. Okay, whether the person is male or female, accordingly his consumption, it will be affected. The third one, it can be the education. So education also, it may affect the consumption of the individual. So all these factors are actually not included as the independent variable. We have taken only income as the independent variable, and we are assuming that income will impact the consumption. But in the real world, apart from income, there can be other factors like age, gender, education, and so many other factors it might be there which may impact the consumption of the individual. So we need to include all of them as a error term, and we'll see how much will be our estimated value and how much will be our actual value. So if actual value will be equal to estimated value, that means we will say that there is no error, the consumption is only changing because of income. But if there will be a difference between what we are estimating about the consumption when income changes and what will be the actual value, if there will be a difference between actual and estimated, we will say that that is a error, and that error it might be because of the other factors. That means the error will be equal to C minus alpha plus beta y. Okay. So here alpha plus beta y, here it can be the estimated value of alpha and beta. If the person's income increases, his income increases from 0 to 1000, and how much will be his consumption? Suppose his consumption is increasing from 100 to 200, and it is the actual consumption. Okay, but you suppose estimated that the consumption it will be increasing from 100 to 300, then the error will be equal to actual minus the estimated. Actual minus estimated. So the estimated value, you can just write this like as this, that is C minus C hat. So here the actual value is 200, but you estimated that if income will increase from 0 to 1000, then the consumption will increase from 100 to 300. So the error will be actual minus estimated, that is minus 100. That means you estimated the the consumption will increase by more, but actually consumption increase by the less, and the difference between the actual and estimated, it is called as the error. This might be because of some other factors which may have impacted your actual consumption behavior. Therefore, your estimated value become a different value than the actual value. So, I hope you are able to understand about this difference between the mathematical model and the econometric model, and what is the importance of error term in the econometric model. Please like, share and subscribe to our channel for more simplified video on economics and econometrics. In our next video, we'll explain in detail about the error term and the role of error term in the econometrics, and how to measure or control this error. Thank you so much.